We introduced Joint Action Storyboards, a framework for visualizing communication grounding costs. Joint Action Storyboards, or JASs, are a framework for analyzing and articulating the impact of user interface elements on collaboration and more specifically on communication grounding. JASs are also for identifying potential redesign opportunities. The framework adapts concepts from Clark and Brennan's theory of communication grounding to analyze brief yet frequent and critical interactions in collaborative tasks. JASs are an integrated framework that fill gaps in existing methods for understanding and articulating the sometimes subtle impact of user interface elements on collaboration. The framework was specifically designed to apply to collaborative systems. Unlike traditional analysis methods such as conversational analysis, JASs include interactions with technology. You can analyze cases where the interface hinders collaboration and breakdowns in interaction happen. Existing task and user level analysis methods such as GOMS were designed to model single user behavior, and also they allow for modeling expert user behavior only. JASs facilitate a fine-grained analysis of brief yet frequent interactions that are critical to the progression of the collaborative activity. Existing methods, such as heuristic evaluation and walkthroughs, have a broad unit of analysis and may thus miss to flag a redesign opportunity. Finally, JASs are not only an analysis framework, but also a communication tool that researchers can use to articulate how a design choice might ultimately impact collaboration. How can you, as an HCI or CSCW researcher, use JASs? You can use JASs to capture physicality in interactions in, for instance, AR, VR, and multi-device systems. JASs may be used as a formative discount evaluation tool. They can also be used as a summative evaluation tool alongside other methods, such as questionnaires, thematic analysis, and conversational analysis. Indeed, communication grounding is an essential part of collaborative activities. You can think of it as being on the same page and maintaining that shared understanding throughout a conversation. For instance, consider two people in a Skype call. Their common ground includes what they both know about the status of the remote call and also what they believe the other party is aware of. Now consider the case where the call is disconnected in the middle of the conversation. This is what the JAS looks like for our Skype example. Each JAS comprises three parts. At the top of the JAS are the scripts providing a narration of the story. In the middle are the storyboards that illustrate the collaborators' interactions with each other and the environment and their mental actions. Finally, at the bottom of the JAS, grounding costs are marked. You can think of grounding costs as a way of measuring the effort required to maintain common ground. JAS show grounding costs incurred due to the user interface of the system. Now let's walk through the JAS to better understand its components and what they show. At first, collaborator A is talking and B is listening. Then collaborator B sees that the audio and video signals are breaking down. Note collaborator B's mental state is understanding a breakdown. At this moment, collaborator A incurs production costs as they talk while their collaborator cannot hear them. Both parties also incur delay costs since their conversation has been paused. Next, the listener asks the speaker if they can hear them. Notice that production and delay costs continue to incur. A's mental state here is not noticing the problem. The listener also pays understanding costs due to lack of contextual cues. Next, when the listener sees that A is still talking, they finally realize that the call has indeed been disconnected. They then end the call, At this time, the group starts paying repair costs as they try to fix the disconnected call. The speaker now pays understanding costs since they don't know why the call was suddenly ended. The speaker then calls again, and thus both parties pay a cost to start up their connection. Then the listener answers the call and tells their collaborator that they could not hear them and that's why they hung up the call. Notice that the group continues to pay delay and repair costs. Next, the speaker says that they had not noticed the audio and video breaking up. The listener then says, let's pick up where we left off. Finally, now that the collaborators have fixed the breakdown, they can resume their conversation. As a technology designer, JAS can help you identify grounding costs, especially the persistent ones that span multiple panels, and think how to alleviate them. For example, look at production costs that are circled in red. How could the interface elements be redesigned to reduce production costs, meaning the speaker won't have to talk while the call has already been disconnected? This JAS illustrates a potential redesign of the interface. Grounding costs could be reduced if a warning sign is displayed as soon as the call is disconnected. The group would then start fixing the problem sooner and thus pay fewer grounding costs. In our paper, we demonstrate some key benefits of JAS through a series of case studies. JAS's visual format depicts physical interactions between collaborators and a CSCW system that are often difficult to understand and articulate using traditional analysis techniques. In these cases, JAS provides a comprehensive method to understand and articulate connections between physical and mental actions and features of the system, and the impact on collaborative processes. Two case studies are shown here. The JAS illustrate how the collaborators reorient their body or their devices due to features of the system during a conversation. They also capture the impact of the physicality and interactions on communication grounding. JAS may be used as a discount evaluation method, for instance, to assess how well a technology supports or hinders communication grounding prior to running a user study and by considering potential technology use cases. The example here shows the Tilt-to preview technique by Mark Ward and colleagues. The JAS highlight persistent grounding costs incurred by the speaker as they must keep a touch and a tilt gesture when transferring a picture to their colleague's device. As an HCR researcher, you may think how the transfer technique may be redesigned to reduce grounding costs and thus better facilitate collaboration. JAS may also be used alongside other methods, for example, questionnaires, video analysis, and observations, to study the impact of technology on communication grounding to provide a holistic view of the system. Those existing methods usually capture data that are observable in the physical world, making them appropriate for identifying certain instances where technology potentially impacts collaboration. In the case study shown here, JAS are used to articulate a breakdown seen in the video analysis results. We hope that you apply JAS to your work. We'd be happy to hear how the framework benefits your research, so reach out to us with questions or comments.